Hello friends, in this video I am going to show you how to check bending for web. This is the third video of section classification video series. If you didn't watch previous two videos, I recommend you to watch because some results I calculated from previous videos might be used in this calculation. This is the map for our calculation. I did bending for flange. Now I am going to do bending for web. So in this video, we will see how to check bending for web. For this check also, we should have the Eurocode 3 design of steel structures book. I hope you already downloaded this book because in previous video, I showed you how to download this PDF. Then open the PDF and turn page 42. In page 42, you can find a table. Table name is table 5.2 sheet 1. So here you can find this column which is part subjected to bending. So in this video our target is bending check for web. Therefore we have to select this column part subjected to bending. That means these formulas are used for bending check. As I explained you before, first we check class 1 condition. If this is not satisfied, only we check class 2 condition. That's how we do our calculation. So we check first condition, which is class 1 condition, this one. So this is the formula used for class 1 check. Let me see meaning of these parameters. Using these figures we can understand what the C is. So here you can see C is this length. This length is the distance between fillets. So we already know that because in section properties video we found that easily from the steel blue book. So here you can see I marked D here. This is the depth between or distance between fillets. So in this figure this C means this figure is simple D. We already know this value. This value is 476.5 millimeters. So I already showed you how to extract this from the steel blue book. If you didn't watch previous videos, please watch video 1. There I already explained about how to get these lengths. So C is equals to 476.5 millimeters. Then we have to find this simple T. In this figure you can see T is the thickness of the web. Thickness of the web also we found before. So this is the thickness of web TW. TW is equals to 14.7 millimeters. So now I know TW, which means this simple T. I can write simple T equals 14.7 millimeters. Now I know these two parameters. Then I can find C over T ratio. C over T ratio is equals to 476.5 over 14.7. So when I simplify it using calculator, I can find 32.4. This is the C over T ratio. Next we have to find 72 epsilon value. So I will write C over T ratio here. Then epsilon. Epsilon is equals to 0.94. How did I get it? Because in previous video I explained all about this epsilon and how to calculate it. If you didn't know how to get this, please watch video 2. I will put the links of videos in the description area. So there I explain about this epsilon and how to get it. So since we already know the epsilon value, now I can find the 72 epsilon value. 72 times 0.94 equals 67.7. So now I know both values, which are COT and 72 times epsilon value. Now I can compare these two values. So 32.4 is less than 67.7, which means COT ratio is less than 72 times epsilon. That means class 1 condition is satisfied, which means web class is class 1 plastic. Okay, now we did all the bending checks, which are bending check for flange and bending check for web. Now we can summarize. So flange class is class 1 plastic. Also web class is class 1 plastic. That means overall section class for bending is class 1 plastic. That's how we do bending check for flange and web. Our next task is to check compression for flange. So in next video we will see how we find compression for flange.